Okay, record is on.
Hello, everyone. Welcome to a new CRID Webinar Series. Thank you for joining us in today's session titled KEEEN, Integrating Robotics in Architecture Fabrication. Please join me in welcoming our guest speaker, Alessandro Tassinari. Alessandro is an architect experienced in robotics and 3D printing for constructions. He is founder of KEEEN, a deep tech venture that focuses on the integration of innovative technologies in the construction industry. He founded the most read Italian website about 3D printing, Stamba3dforum.it, and contributed as a consultant to develop additive manufacturing strategies for many companies. Joining Carlo Ratti company at the end of 2016 as a head of digital prototyping and fabrication and as a senior architect. Before giving the stage to Alessandro, I would like to invite all the attendees to type their questions in the Q&A section or to send it privately to me. Welcome, Alessandro, and the stage is all yours.
Thank you. Thank you very much. So I'm going to share my screen. Here we go. So hello, everyone, and welcome to this seminar. We're going to talk about robotics applied to architecture fabrication, a topic which is very important to me, and that it's gaining more and more interest also from the market point of view. So the construction sector is facing key challenges to stay competitive. Right now, we have a real problem related to the fragmentation of specialized expertise. Also, there is a lack in tech sophistication in construction, and this contributes to, for example, job delays, missed budgets, and increased job site safety risk, for example. So there are many questions which need answers, like how can we innovate the construction processes, or how is it possible to make a smooth transition to new construction methodologies? Well, today we'll try to give answers to these kind of questions, briefly touching many topics. Each topic is strictly related to the construction sector, but sometimes, as you're going to see, we'll take some ideas also from other industries that and sectors that already did a step forward in technology integration, and that, unlike the construction industry, moved into a technological transition that changed forever the way to work. So let's start from the basics. In the recent decades, we dived through a huge and important transition connected to technology, basically. If we think about the general industry years ago, production and manufacturing activities were less sophisticated, but the target was to optimize the production and to make the industry more competitive. So to do that, someone developed like a method to enhance the production sophistication. So firstly, we got the Toyota production system. The Toyota production system was a model developed in the 30s and was the operational system that allowed Toyota to become one of the biggest companies in the world. The Toyota production system was based on a series of principles that had the target to enhance the production through a very deep activity of problem solving and process optimization. The Toyota production system is the father of other optimization methodologies that have been developed, like the lean production system, lean manufacturing, and another one which is concurrent design. So the last one, so concurrent design, is very important for us, and the reason is mainly one. It's because it's strictly correlated to production. So concurrent design is a group of design methodologies and techniques that consent to approach design in a new way, let's say, in which you can you can take into account every aspect of design and production. So just to make some examples, some aspects that are part of concurrent design are procurement, cost, reliability, also reuse, disassembly, assembly, safety, etc. So everything is strictly connected to the product design and its fabrication processes. There are many benefits in this approach. So there is a very strict correlation in between design and fabrication, and we know architecture is something quite complex, right? So I'm sure that you can agree with me, because architecture always requires meticulous attention to detail. Also, if you think about how many buildings need bespoke and tailor-made solutions in their components, like the structure or the facade components, for example. So robotics in architecture fabrication is a technology that allows to the fabrication of buildings or part of them using highly industrialized processes. And in our field, we can see robotics as a mix of technologies, procedures, and techniques that go hand by hand with traditional construction and assembly technologies, and that allows to fabricate in a completely digitally controlled way. So starting from this description of digital fabrication and robotics and architecture fabrication, we can now find some connection with the introduction I did on industrial production methodologies. Robotics in fabrication is a technology that drastically enhances the abilities to produce parts in a fast and immediate way. It is a technology that permits to keep everything under control during the process that goes from design to fabrication. So as you can see, there is always this very strict and huge connection in between those two phases of these activities. So robotic fabrication is a production methodology that refers to various technologies that use robots as the main hardware to fabricate buildings or construction components. So robots can be used for cutting, for milling, for welding, or for example, 3D printing. Basically, we could say that depending on the tools used by the robot, the process get a different name. Like, for example, in 3D printing, sometimes we can read about robotic fabrication or large-scale additive manufacturing. All these terms refer to different systems that use 3D printing technologies with the same purpose. In this specific case, to fabricate buildings or, again, components, small components of them. So said that, let's talk about what differentiates robotic fabrication in architecture from traditional building construction. Just to be clear, I'm not here to say that robotics is going to be the unique way to fabricate parts of building. What we can say instead is that robotic fabrication is going to be something that will change forever the way we concept, we design, and we fabricate part of building. So we are going to talk about a connection between traditional construction methodologies and new construction methodologies. So when we speak about traditional building construction, we mean all the technologies that and modalities that have been consolidated into the market, both from the business and the technical point of view. To mention some of them, we can say that wood construction, concrete construction, or prefabrication in construction are methodologies of building that we perfectly know. And of course, we can innovate in these fields. Sure, we can, for example, find new way to connect timber beams together, for example, or we can optimize a new cement mixture, or again, we can design like a new prefabrication system. The thing is that we use, let's say that the basics of the technology that we use in these cases is always the same. I mean, also the knowledge that we use is the one that we already know in these specific cases. So robotic fabrication is something different, also in the kind of in the approach that you can have in the architecture construction fields when you try to do innovation or maybe to integrate this kind of new technology into architecture and construction. So there are different motivations for why I'm saying that, and I will try to summarize it in a few points. So robotic fabrication is something that comes from industrial concepts. So this means that this technology has an industrial soul, and it involves skilled laborers in every project stage. And then also robotic fabrication involves new technologies altogether. That means, this means that when we speak about robotic fabrication, we are speaking in the meantime of robotics, but also automation, IoT, etc. And the third point is that design activities are really different from designing a building that will be fabricated or assembled with traditional technologies. So there is like a new way to design the building or the components of the building. Another very strong connection is between robotics in architecture and the environment. So we are all aware that the construction industry has the highest carbon impact, which accounts like 40% of global energy consumption and something like 38% of carbon emission in the environment. Thus, there is great demand for decarbonization in this industry. And for an example, 3D printing or additive manufacturing has emerged as a potential solution to reduce the energy demands, the water wastage, for example, but also the carbon emission. So to summarize, we can now do a very brief list of advantages and limitation of the current state of robotics in architecture fabrication. So we were talking about this kind of environmental connection. So basically, the good thing is that we can use robotics and let's say also new technological approaches to enhance the use of materials and processes which are more environmental friendly. So you can use, for example, raw soil and natural waste from the rice production to 3D print part of buildings. This is just only a small example. And then there is also another benefit, which is related to the cost reduction in fabrication of the in construction. So we can be faster, for example, in producing in the production of components. So basically we save time and we save money. And also there are a lot of advantages in the design field. So we can generate shapes that are impossible or too expensive to manufacture otherwise. Speaking about the limitations, the first one, I think that is the cost of the hardware, which is today still very high. Yeah, I mean, we need to buy machines. We need to understand how to integrate it with the processes that we want to use. So this is a very, this is still a very huge limitation. And then there is also like a limitation connected to the skills that the professionals need to have and to be involved in these processes, because the processes are really in between the industrial sector and the design and construction sector. So there is like a merge of skills. And then also we still need an optimization of the energy consumption in this technology. So, you know, also in the construction industry, there is this kind of problem. There is the problem of energy consumption in the whole processes that we use. But also in this case, I mean, we have the benefit that we are developing new processes. So if we start from the beginning to think how to optimize the energy consumption, so then everything will go smoother. So the main reason many universities and companies are interested in this solution is that multi-axis flexibility of the machines compared to the conventional 3-axis machines we use gives new opportunities in fabrication. So as you can imagine, thanks to the multi-axis capacity and in movements and rotations, robot arms literally open up new opportunities in fabrication in fabricating complex parts, especially through 3D printing and assembly activities. Also, a very interesting characteristic of this of robotic fabrication, referring to it like a method of fabrication, is the fact that to fabricate objects with like overhangs, supports, and let's say with structures which are quite let's say complex to build usually with traditional processes is going to be easier. So like, for example, 3D printing, you don't need the supports to print and to fabricate some shapes. Also, of course, using this kind of processes, the freedom in the design is enhanced, and the money and the material that you use, I mean, the material cost will be reduced, and of course, the cost of the projects will be reduced. So until now, we talk about the processes. We saw some nice pictures of small structures that have been developed, but one of the questions could be how we manage the process and how we program the machines. I mean, mainly we are architects, we are designers. So how are we able to approach this kind of machines? So to program a robot to fabricate objects is something not so difficult, I would say. Software already spread around the industry, and use cases with construction materials like concrete and clay have become very common. On the other hand, to program a robot to fabricate objects can be a bit tricky. As we know, to fabricate using digital fabrication, means to know the fabrication process and all the variables like the material characteristics, the location of the building site, like maybe you are planning to work on site, or maybe you are planning to work off site, so into a more, let's say, secure environment. Also, you have to take into account what you want to achieve, like also to know perfectly the geometries of the object that you want to fabricate. So you have to be able to understand which are the final needs of your fabrication process. So, of course, I mean, there is also another feature to take into account, which is the possibility to apply in a very complete way the design to the fabrication process. Like, we have to go deeper in this connection, in this link that we want to achieve. So using Rhinoceros and Grasshopper as a design platform, for example, we are able to model the object and to directly transform it in code, and that this code is immediately can be immediately sent to the machine for the fabrication phase. So there are many plugins that you can find online, but you can also develop yours. And there are also many companies which are developing internally processes which links the design that you do through Grasshopper, and then connects it to the machines for the fabrication phase. So basically, we can make simulation, and we can design the toolpath in a very fast and effective way using this kind of design tools. This is very important because if the designer is not prepared to do it, the accuracy of the fabrication and the fabrication opportunities could not be brought to its maximum, let's say. So sometimes also causing errors in the fabrication and damaging the machines. So taking this observation into account, it's normal that robotic fabrication is still a system I mean, it's a system which is very appreciated in our context. And also, at the moment, the situation is very early, and it's very easy to see companies try to match industrial robots, both from a manufacturer to the hardware, both from another manufacturer. But this is also the most interesting part, I think, of this work right now, where companies are trying to pushing the boundaries and are trying to develop their own solution to solve real problems. And the solution can be found in the hardware, but can be found also in the software. So to recap, we said a lot of things here, so let's use a short list. So first of all, we said that robotic fabrication is a system, and that allows to fabricate components and uses machines that has more than 3 axes of freedom in movement. So this enhances the opportunities in fabricating complex parts and to reduce the quantity of material in using in the fabrication phase. Then we can say that this technology brings to construction some benefits that already are part of the general industry, like connectivity, software interoperability, and yeah, also other technologies which are not still implemented in the architecture, fabrication, and construction fields. Then we can say that robots are quite precise and fast, and I mean, are probably too precise for our context. and are can be really too fast in our context. But anyway, this is something, this is a benefit. This means that we can push the fabrication activities and we can also achieve new targets. And then we can say that the dimensions of the component that we can fabricate may vary. So it depends by the dimensions of the machines, but also by the projects that we are dealing with. Then we can fabricate on site and we can fabricate off site. So there are, I mean, this depends a lot from the project and basically from the project needs, let's say. So usually off-site fabrication is preferred because you work into an environment which is controlled from the temperature point of view, but also from the from many point of view, let's say. Instead, if you want to work on site, of course, you have to deal with many problems. Also, the hardware that we use is very versatile. So you can use like the main hardware that we use is the robot arm, but you can change the tool that the robot uses to fabricate different kind of objects, to use different kind of materials. So this is, when I talk about versatility, I mean this. And then, of course, I mean, we already said that there is this connection in between design and fabrication. So through the softwares that we saw, we can connect the two phases, those two main phases, and to find new opportunities in fabricate parts of buildings. So here I have just some pictures and examples. So we can see robots that are used for milling. So, and this is like probably the most traditional activity in which industrial robots are used. So basically, you can mill different kind of materials from plastics to stone, and you can fabricate geometries which are quite complex, and of course geometries which can be assembled on site. But again, we can use robots also to fabricate components through hot wire cutting. So basically, if you have a volume of material, you have this kind of wire which is used to cut the material and to basically to shape the material for the fabrication of the part. And then a very common technology today, so concrete 3D printing. So basically we have an extruder that deposits the material by layer. So basically we are able to print concrete, we are able to print clay, we are able to print different kind of materials, also plastics, and we can scale the technology depending by the dimension of the hardware that we use. But anyway, I mean, also there are many examples of big 3D printers which are mainly 3-axis 3D printer, and that showed us that we can print the main structures of the buildings on site. And again, another interesting technology, it's metal 3D printing. So basically, we have a very special extruder, which usually, I mean, when we want to reach big dimensions, welding tools are used in this case. So the robots are used to move the tool in different axes, and the material is deposited into the printing volume. So now I'm going to finish my presentation. I just want to summarize also the benefits that we let's say decided to incorporate in our activity in our company. So there are 3 main pillars. The first one is the tailor-made solutions that we can propose to our clients, for example. So, we have always to see the connection in between research and the business and what the industry needs. So the industry usually asks for tailor-made solution for bespoke components. The second pillar is the on-demand production. So basically, you don't need to fabricate a lot of components and to store it and then to move it around the world. So basically, we fabricate only when we need to fabricate. So when we have when the project is done, when the design is done, we move to the fabrication phase, and it's specifically in that moment that we go to fabricate the components, that we can take advantage of distributed facilities around the world. So basically, we cut the movement of components around the world. We design the components in a digital way. So we have digital files, and we use the cloud and we send it to the fabrication facilities. We can be near to the building site. So also we cut the CO2 emissions coming from the delivery of the components around the world. And this is the physics that we follow in our activities. So as we mentioned, we have a design phase, we have a fabrication phase, which are strictly connected, and then we deliver the parts on the building site. And in our case, we are using two different kind of processes. The first one is plastic 3D printing. So we are trying to move to the large scale 3D printing fabrication. So basically, we are using plastics in pellet to push the flow of material that we can use. So we want to print plastics in high volumes. Also, we always use recycled plastics because, in our case, our components doesn't need to have really huge, to be very strong, let's say, in its mechanical characteristics. So if we use recycled materials, it's enough. And again, we use a distributed facilities around the world to cut the CO2 emissions. And then the second process that we use, it's connected to metal 3D printing. So we use wire arc additive manufacturing, which basically uses, it's like welding activities, but connected to the machines. So we fabricate 100% metal alloys like titanium, inox, iron, and brass also. I mean, different kind of materials. And we are able to fabricate different kind of shapes, which are quite uncommon in our industry. So here you can see some examples, and also inside the fabrication facilities. So in this case, I think that this kind of shapes are quite interesting because, you can fabricate pieces which have, in which the weight is reduced compared to traditional traditional components, but you can also deal with different kind of shapes. And here you see a picture of the fabrication process into one of the smaller machines that we use. So basically, yeah, you see the welding machine, which is depositing, which is basically extruding the material dot by dot. And on the right, you can see the final object. And here you see other pictures of this fabrication process. So yeah, that's it. Thank you very much.
Thank you so much, Alessandro, for this informative and interesting presentation. We have some questions here. So let's start with the first one. What is the speed difference between the traditional way of fabrication and the one using robotics?
Well, the main difference, I think that it's in the way you have to think, or maybe you have to design the components. So I'll do an example to explain this. Like, just imagine that you have to design, I don't know, like the interior walls of a structure. So if you are, I mean, how you design it, the shapes, the materials, also the dimensions of the materials, of the width of the walls, and I mean of everything correlated to these specific components of the building is strictly correlated to the fabrication process that you use. So I think that the main thing is starts from the beginning, so from the first step, which is the design one. So in the design phase, you have to understand how you want to fabricate the components, and then the rest come by itself. So I mean, you can fabricate something through 3D printing. Yes, you can, but you have also to deal with the mechanical resistance of the components, like for example, or maybe you want to you are just interested into the design in the shapes of the components. So maybe you can mix a traditional way to fabricate the structure, and then you can apply onto it components which are fabricated using a different technology. So I think that everything is really in the design field.
Okay, moving to another question. What are, in your opinion, the opportunities for 3D printing for parametric design and architecture projects, and any benchmark of a successful project?
Well, so so talking about 3D printing, I mean, this is a very, let's say, interesting technology, and you can do really a lot of things with this technology, also because you can deal with different kind of materials. So I think that also it's a technology which is quite versatile in dimensions. So you can deal with let's say small objects, but also with quite big objects. And specifically in our field, in the last years, there was a lot of research, and also a lot of papers were published in which basically we understood how the materials can deal with some aspects, like again regulations, and also with the let's say also with the specifics of the material that we have to use. Anyway, you can print metal, you can print plastic, you can print concrete. I think that, I mean, it's not possible to do like a benchmarking of, let's say, of projects. I think that this is an ongoing process, and that also I think that we have to deal with the specific problems of each project. I don't know if you, I mean, if
yeah, I think it's clear. So yeah, moving to the next question. Do you think that the robotic fabrication will eventually replace the traditional way?
Well, in some fields, yes. I think that there are processes which are not common today and that will disrupt some industries. I think so, yeah. but not in every field.
Okay.
I see a future in which we have both.
Okay. Yeah. So, a last question: do you have any insights on how the AI is going to empower the robotic fabrication?
Yeah, sure. So, you know, AI, we're talking a lot about AI in the last month. There are some research projects in which you can see the connection and let's say some trial of integration of AI computation in the design field. And I'm not just talking about the production of images, so renderings, but also in the production of point clouds in the digital softwares. So if you imagine, let's assume to be able to ask to an eye to produce a point cloud into a digital environment, we can use this point cloud to generate surfaces that then can be fabricated. So I think that this field is the most interesting in our case. If we want to reach this connection in between AI, what the AI can do, and the production of physical components.
Yeah, so thank you so much, Alessandro, for being here with us today.
I have just one, if you don't mind, Hadil. So
yes,
Alessandro,
yes,
thank you so much for being here. And thank you for the very informative, webinar. I just want to ask you about, do you see any chance to be able to have a 3D printing combining concrete and metal, in a sense that you could have a reinforced 3D printing where, it can hold itself, it can be structurally, and the integrity of the structure could be there. Do you see any possibility of that type of creation anytime soon?
Well, yes. Also because we did some projects, let's say, in this field. So basically, you saw the small pieces that they showed in my presentation, like the last pieces, which are diagrid structure. So imagine if you can fabricate this kind of shapes in large scale, and then to cover it with concrete, for example. So basically, you are printing the skeleton of the wall in this case. So right now, I don't see the perfect integration, if you meant that, like the integration of metal and concrete in the same time, but I see two different processes that can be merged.
Okay. So at the moment, there's no way to do it together at the same time. It has to be two different processes.
Yeah, I think so. I mean, maybe someone developed it, but yeah.
Okay.
I don't
know. Thank you so much.
Okay. So thank you so much, Alessandro, for being here with us today, and thank you for everyone attending our webinar.
Thank you.